What specific problem does Milabench aim to solve in the context of GPU selection for AI workloads?
Milabench aims to solve the problem of selecting the right GPU for AI workloads by providing a comprehensive benchmarking suite that reflects the diverse and complex nature of AI research conducted at Mila. It addresses the inadequacy of simple kernels or synthetic benchmarks, which fail to accurately replicate real-world AI workloads. By incorporating a wide range of benchmarks, 26 main and 16 optional, that cover various research domains, model architectures, and scaling pipelines, Milabench ensures that the benchmarks are representative of actual usage patterns. Additionally, it avoids vendor-specific optimizations, promoting unbiased evaluations across different hardware solutions. This systematic approach enables researchers to make informed decisions about GPU procurement, optimizing performance within budget constraints.
How does Milabench work? Illustrate its methodology step by step, detailing components like Milabench, Benchmate, Voir, and TorchCompat.
Milabench operates through a structured methodology that involves several key components: Milabench, Benchmate, Voir, and TorchCompat. First, the Milabench component manages the entire benchmarking process, including configuration, execution, and installation of necessary dependencies and datasets. Next, Benchmate provides common utilities that can be reused across different benchmarks, such as custom monitors for logging metrics. The Voir component serves as an instrumentation tool that retrieves and logs performance metrics, including GPU monitoring for various vendors. Lastly, TorchCompat acts as a compatibility layer that smooths out differences between vendor implementations, allowing seamless execution of benchmarks without code changes. The execution process is organized into three main steps: installation of virtual environments and dependencies, preparation of datasets, and the actual execution of the benchmark suite, which can be customized via a YAML configuration file.
Can you provide a simple illustrative example of how Milabench benchmarks a specific AI model? Walk through this example, explaining the steps involved.
Milabench benchmarks a specific AI model, such as BERT, through a structured process that involves several key steps. First, the benchmark suite is configured using a YAML file that specifies the BERT benchmark parameters, including the model architecture and execution settings. Next, the setup phase creates a virtual environment for the benchmark and installs necessary dependencies, followed by downloading required datasets. Once prepared, the benchmark is executed, where it runs multiple iterations to gather performance metrics, such as processing time for training or inference tasks. Finally, the results are aggregated using a weighted geometric mean to provide a comprehensive performance score, reflecting the model's efficiency across different GPU configurations. This systematic approach ensures that the benchmarking process accurately mirrors real-world usage scenarios, allowing for reliable comparisons across various hardware platforms.
What are the theoretical or practical benefits of using Milabench compared to existing benchmarking frameworks, particularly in relation to real-world AI workloads?
Milabench offers several theoretical and practical benefits over existing benchmarking frameworks, particularly in its alignment with real-world AI workloads. Firstly, it emphasizes standardized implementations that ensure robust reproducibility and generalizability of performance across similar pipelines, addressing the limitations of vendor-specific optimizations found in frameworks like MLPerf. Secondly, Milabench is designed to mirror the experimental pipelines commonly used by researchers, which allows for accurate performance measurements that reflect actual usage scenarios, rather than relying solely on synthetic benchmarks. Additionally, the suite incorporates a diverse range of research domains and model architectures, ensuring comprehensive coverage that aligns with the varied AI research conducted at Mila. Finally, Milabench's modular and user-friendly design facilitates rapid experimentation and customization, making it easier for researchers to adapt benchmarks to their specific needs while maintaining a focus on real-world applicability.
How is the Milabench suite validated or tested? Explain the experimental design and metrics used to ensure its effectiveness.
The Milabench suite is validated through a comprehensive process that includes a literature review and manual annotation of research papers. Specifically, 867 papers published by Mila researchers in 2023 were analyzed using the Paperoni utility, and key information was extracted with the help of GPT-4o. To assess the accuracy of GPT-4o's predictions, a validation set of 110 papers was manually annotated, ensuring a balanced distribution of research topics. The performance of GPT-4o was evaluated using a multi-label confusion matrix, MLCM, focusing on the accuracy of predictions for research domains and model types, achieving recall rates between 84% and 98%, and precision rates from 86% to 100%. This rigorous validation process, combined with the hierarchical taxonomy created for domains and models, ensures that the benchmarks in Milabench accurately reflect the research landscape at Mila and are effective for benchmarking GPU performance.
What insights did the literature review and surveys reveal about current research trends, and how do they influence the benchmarks included in Milabench?
The literature review of 867 papers published by Mila researchers in 2023 revealed significant insights into current research trends, particularly highlighting the prominence of reinforcement learning, RL, and natural language processing, NLP, which were found to be equally important at Mila, contrary to expectations that computer vision, CV, would dominate. This understanding influenced the selection of benchmarks in Milabench, ensuring that they accurately reflect the distribution of research domains, with RL being newly incorporated into the suite. Additionally, surveys conducted among professors identified popular libraries and suggested benchmark pipelines, although these responses were biased towards CV, necessitating a reliance on the literature review for final benchmark selection. The benchmarks were thus designed to cover a diverse range of research topics and model architectures, ensuring that they align with the actual usage patterns observed in the literature. Overall, the combination of literature review and surveys informed a balanced and representative benchmarking suite that addresses the evolving landscape of AI research at Mila.